So about a year ago, I decided it was time to jump into the CNC world. I'd played around with a 3D printer a little bit and decided that it was something that I enjoyed doing and I had a little time on my hands. So I found myself over to V1 Engineering's version of an inexpensive CNC platform, which you can see right here. This is their website. It is v1engineering.com, and I'll leave a link down in the description. But they make, or they designed, Ryan designed a platform called the Mostly Printed CNC, and it's exactly what it is. With a 3D printer, 5 NEMA 17 stepper motors, a small controller, and some EMT metal conduit, you can build one of these. The entry price for these is extremely affordable for what you get. About 300. I had roughly $350 in my build. My build's a little bit bigger than their standard build, if you will, with a 24 by 24 cut area. So you really can. He advertises now that you can get it, for I think under $550. You can really beat that price if you shop around and you get some cheaper motors and controllers, etc. You real small stepper motors needed for this. I think I got my whole all 5 of my motors off of eBay for, I want to say, $45, which was less than $10 a piece. So the Mostly Printed CNC is, for what it is, it's great. I've had a lot of fun with mine, but I have kind of outgrown it, which I think you will too. But for the average new CNC user, this is a great project. Handful of nuts and bolts, these 3D printed parts, and a sleeve full of roller skate bearings, and you're in business. And I will tell you that this thing, it cuts accurately. It's a little slower than some of the others out there, comparing it to your Shapokos or your X-Carves, but it's at a fraction of the price. And one of the downfalls that I have found with the Mostly Printed CNC is all of the connections rely on 3D printed plastic parts. And you can run into some rigidity issues with that, which I have. The only thing I have found that really runs into problems is if you're trying to V-carve on a piece of wood that has multiple densities, such as pine. If you look at a piece of pine and each one of the successive rings or layers in that grain pattern is a different density. And I have noticed that whenever I'm trying to V-carve and it hits those different densities, it will throw my lines off a little bit. Again, that's not knocking the Mostly Printed CNC. I think it's a good build for what it is. It just doesn't do everything that I want it to do. Now, there's guys out there that are making these things super rigid. They're adding epoxy granite to the tubes. They're super duper printing with high performance plastics for all of the connections. And they're getting some really good results out of these. If it's your first foray into CNC and building a CNC, I think this is the way to go, because it literally is, it's cookbook CNC. You go to Ryan's site here at V1 Engineering, you can pull up all of the information that you want, including somewhere in here there's a size calculator. Here it is, and this will tell you if you want to print. I'm going to do Imperial because I'm here in the good old US of A. And you can select your sizes. You want to cut 24 by 24, dial it in. I think you could actually probably poke the numbers in and be a little faster, but we got this going already. So there we go, 24 by 24 workspace. and that will give you all of your tube lengths. It will tell you that you need two tubes for your X rails, 36 inches, one for your gantry at 33 3/4. For your Y, you need 36 1/4, 34 1/4, and so on and so forth. And it will tell you exactly how many inches of tube. So I know for this one, I would need probably 3 pieces of 3/4 inch EMT conduit. Total cost $30. It will tell you your belts, your lead screw, all of that. It will tell you your table size that you need. This is a really, really good calculator. Pretty much with this and the STL files that you can get off of, I think you can still get them off of Thingiverse. It took probably 2 spools of filament to get all this printed out. I did print mine in 2 different colors just because I wanted to be cool, like Ryan did with his black and red. I used black and mud flat mint because that seemed like the good thing to do. Very good documentation on the Mostly Printed CNC. There's a lot of folks who have built these. I had no problems finding help or answering questions on their website or some other forums. There's quite a few YouTube channels out there. So that's what I built. And I do have, I have a lot of hours on mine. I really have enjoyed it, but I have found that it is time to upgrade. So that's what this video is going to be about, is my transition from the Mostly Printed CNC to the 3Design PrintNC CNC. So if I get those mixed up, just kind of ignore me. But let's get off of this site, and I will actually show you some video and pictures of my build. Okay, so here's the actual build of my Mostly Printed CNC machine. You can see that most of the connections rely on 3D printed parts, which are pretty good. The NEMA 17 motors, there's one on each side slaved together. They move by belts, they move the X and the Y gantry, which you can see cross there to form the Z axis. One of the problems I have is you can see here that there's a little bit of slop in that Z axis, which is caused by the coupler for the lead screw. It's not horrible, and it's not really noticeable unless you're trying to do, like I said, V carving into various things. But there are some rigidity problems with this, and hopefully those will be overcome with the PrintNC CNC. One of the major cost savings with the Mostly Printed CNC is the tiny NEMA 17 motors they use and the drivers, which I'm pointing to here. There's 3 drivers, and those things are cheap. I want to say they're less than $5 a piece, and they're all resting on a CNC shield for the Arduino Uno, which that whole shooting match is probably under $25–30. It does use EMT conduit and these 6mm belts. So this is my solution for my rigidity issues. This is a design made by 3Designs. The gentleman's name is Mark Hogan. He is in Queensland, Australia, and this is the first version of this that I have seen, and it's pretty awesome, especially considering that all of your connections are steel on steel and through bolted. Still a fairly simple design. This design I don't think is as mature as the Mostly Printed CNC. There's still a whole lot of development going on, especially if you choose to build a design that is different than what Mark has on the website. He has I'll call it a standard size that this is designed, and this is actually a mock-up of that standard size here. I don't remember exactly what the sizes are, but one of my goals with building my own CNC was I wanted to be able to cut at least a half sheet of plywood and a full sheet by tiling. Not that I ever intend to cut anything that big, but if you're going to build it, you might as well go big or go home. But the 3Design, and I'll put a link to his website down below. It is adaptable, but you can see everything is rectangular tube steel, and it is much more rigid than the 3/4 inch EMT conduit that the Mostly Printed CNC uses. While this is called a PrintNC CNC, most of your printed parts, which you can see on this Fusion mock-up, are going to be, all of your printed parts are the red parts that you see here. And there's not many, and they are not at connections, and the machine does not rely on those printed parts for rigidity. Much less printed parts on this machine. Most of these are just kind of spacers to hold these blocks where they need to align. Again, these connections here are all pretty much steel on steel. Your gantry bolts to a linear slide rail, which all of that, while it's much less printed parts and much more rigid, it is much more expensive. Still way cheaper than a comparable CNC that you would get. Even it's going to be less than even say an X-Carve or a Shapeoko, and especially if you're looking at the like the X-Carve Pro that just came out. Much cheaper. I think for all of my parts, and I've just got a few things left to buy, mainly the aluminum for this Z plate, and I am at about $1,300. So much more expensive than the Mostly Printed CNC. You know, say 4 to 5 times as much, but I think it's a much more capable machine. This machine will definitely keep up with your mainline off-the-shelf Shapeokos, Workbee, X-Carves. Definitely will keep up with those. It doesn't use belts. It uses all ball screws for your motion, which are extremely accurate. However, they are kind of expensive. So Mark drew this up, and it's easily available in a parametric Fusion 360 model. You can go in and change it. Unfortunately, I am not very good at Fusion 360, so I have modeled mine up in SketchUp. So let's take a look at that. So again, here's my model in SketchUp versus the Fusion 360, and that's only because I'm not very good at Fusion 360. I admit that. I'm much more comfortable with SketchUp. I need to learn to use Fusion 360 better. This build would be much easier if you already know how to do that. Again, this is not as nearly as complete of a mock-up as what Mark has on his website for the Fusion 360 model, but it is accurate for my dimensions. And my dimensions, I'm going to be basically 65 by 65 inches. That's about 1,650 centimeters, or I'm sorry, millimeters on each side. I did add an additional Y brace here. The standard PrintNC only has 3. Since I extended so far, I went ahead and added 4. Again, each one of these connections here is steel on steel, and there will be bolts through each one of these connections that hold it. Again, your linear rails, and I'll show you how I came up with my numbers for this, because this seems kind of odd. I mean, 61 by 65 workboard with a 66-inch. How did I come up with those numbers? And I'll take you back over to Mark's website and I'll show you how I did that. One change I did make is, another change I did make, I should say, is this X gantry, because it's so much longer, I went taller. Most of the steel that you see here is 2-inch by 3-inch, but the gantry will be 2-inch by 4-inch. So it's an inch taller, which when you're looking at rigidity, it's much better to go taller than necessarily wider. Now, going taller may increase the moments on these parts, and I may have to do some adjusting over here. We'll just kind of have to see how it goes. I think it'll be fine for most things, but if I try to run it too hot and heavy, there's going to be a torque moment here, which is going to try to move to twist this gantry off of these supports. So I'll see how that goes, but I am set up. I do have additional blocks here. What I plan to do is I will double the length of this block and add 2 of the sliders for my linear rails. I don't think that it's going to be a huge problem, but it may be something that I have to deal with. So let's jump back over to Mark's 3Design website and take a look at how I came up with these oddball numbers. And again, we're back over on Mark Hogan's 3Design website, and that's 3design.store. And again, he is in Australia and has a very good website, very good design. I will say it has not been as easy to customize this design as it was the PrintNC CNC. But if you're going to jump into building this, you need to have some metalworking capabilities. You need to have some 3D printing capabilities, abilities to use a CAD program to go in and make and modify some of your 3D printed parts, just because everybody's going to be a little bit different. Now, of course, like I said, Mark is in Australia, so all of his steel, bolts, everything are going to be metric, whereas here in the States, we're all going to be imperial. I could probably get metric steel, but it would probably be special order. He does have some information in here for imperial measurements. I don't know that those are as refined as they could be, probably because Mark doesn't have access to 3x2 steel that he can put a set of micrometers on and actually get it dialed in. I know some of my 3D printed parts fit a little snug for what I was wanting, but still good. Lots of good information on the PrintNC website. One of the things that you'll want to jump to first is the frame size calculator, and I'm going to show you how I came up with those oddball numbers on mine. So very similar to the Mostly Printed CNC. Here you can input your steel sizes. 3x2 is the standard. You make your adjustment based on your wasteboard size. Now, my wasteboard size I know is 61 by 65. And how I came up with that, and if you scroll down here to the bottom, it will tell you your ball screw length. And kind of what I did is I went on eBay and Amazon, and I found a length of ball screw that was within my budget. Actually, I went to find the cheapest ones, and I found a good deal on some 1550 millimeter ball screws. And I said, okay. So I went back up and I started playing with these numbers to see how big of a footprint I could have and still have these two ball screws at 1550. And I found that the sweet spot for that was a wasteboard of 61 by 65. Again, your biggest cost for this project is probably going to be the linear rails and the ball screws. So once you get a particular size picked out, you might as well go ahead and maximize your steel, because you're probably going to end up buying 20-foot sticks of steel regardless of whether you use half of it or use all of it. So go ahead and my thought process was go ahead and maximize the build for that. And you can see here that my X gantry is 65.98. Who's going to miss 2/100 of an inch? So I rounded up to 66. Your Y supports and your X supports are both 65, so that makes it easier. Your Y rollers and your X rollers, those do not change dimensions based on the size of your build. So they're 2 3/4 and 5.3 inches, or 70 millimeters and 135 millimeters. So that's how I came up with the oddball dimensions for my X and Y footprint, is because I wanted to maximize with those ball screws. I wanted to get the maximum I could. Now I will tell you that the ball screws that I bought, and I probably would have done this different, but maybe not, are 1605. And the 1605 ball screw nomenclature, that breaks down to, it's a 16 millimeter diameter ball screw, and 5 millimeters per rotation. So what that means is every time that ball screw rotates one time, you get 5 millimeters of linear motion. The 1610, which is what I probably should have bought, gives you twice as much linear motion. The drawback to that, again, with mechanics, it's always a trade-off. You're going to need more torque to push a 1610 ball screw than you would a 1605 ball screw. So I'm going to build it with the 1605s. If it doesn't work out, then I will go back and upgrade those. If I upgrade them, I will probably upgrade to 2010s. So now we will go ahead and take a look at one thing that Mark does do quite well, and that's show you where to buy your parts. So one of the nice things about the 3Design website is the buyer's guide. Get there, click on the PrintNC buyer's guide, and it will show you where to get that. Now, Mark has set up a AliExpress store where he works with a Chinese manufacturer, and you can go and order basically everything you need for that kit in one fell swoop. And click on the AliExpress and it will take you, and it will show you exactly how to order all of these parts. You can contact that AliExpress store and they will custom make the parts for you. And in full disclosure, I did not use AliExpress only because I think in the States it's much faster and easier to order from other suppliers. I probably will use AliExpress for my spindle whenever I decide to upgrade on that. But if you want an easy, straight to it thing, click on the AliExpress store and go there, and it will tell you that you need to locally source your steel tubing M5 and M6 bolts and Loctite, and there is a list of those in one of these. I think it's under the bill of materials, which is probably under the assembly, and that will tell you how many of the M6 bolts, how many of the M5 bolts you need. I'll tell you that in the US, I found Grainger to be extremely affordable on those, even cheaper than Amazon or eBay. You could buy 100 pack of each one for less than $10. So I think all of my bolts cost me $45, which I couldn't beat that on Amazon or eBay. Your MDF wasteboard, of course, you're going to source that at your local lumber supplier. Your 3D printed parts, you can download and print those out, and then he has actually a CAD drawing or a PDF for the 8mm aluminum faceplate. And what some guys have done that are building it is they're building the faceplate initially out of plywood or MDF, and then getting their machine set up, and then they're actually cutting that faceplate with their machine as one of their first projects, which I think is kind of nice. I haven't got that far in my thought process yet, so I don't know exactly how I'm going to go about doing the faceplate. But when I get there, I will definitely upload a video of it. So if you're interested in watching how I transition from the mostly printed CNC build to the much more capable, much more rigid, much larger, and much more expensive PrintNC CNC, I'd appreciate it if you'd hang around, maybe give this video a like, go ahead and subscribe. I don't post a whole lot on YouTube, just with my other life requirements, but I will try to update this project pretty regular now that I have sourced all of the parts and have them mostly ready to go. I should be able to start this build pretty quick and get something going. Hopefully by the end of the year, I'll be cutting with this machine. I don't know how long that will take me to video and edit and upload, but I'm pretty excited about this build. Hopefully we'll see the premiere of my helpers on the farm here. I like to call them the Flappettes. So stay tuned for that. It's going to be a fun project. So there you go. Have a good one.